import multinomial NB. We're going to use pandas to import the data, so it's easier that way. And NumPy just in case. Alright, so we're going to load our data. And this is already in the NLP class folder if you checked it out from GitHub. And I'm going to turn it into a raw matrix because I don't need any of the pandas stuff. So np.random.shuffle does an in-place shuffle of the data. So I want to randomly split the data into train and test sets, and I want it to be different every time, so that's why I'm doing the shuffle. And I know that the first 48 columns is going to be my input, so I'm going to call that X. So I want all the rows and the first 48 columns. And Y is the last column. So it's all the rows and the last column. Now since we already shuffled it, it doesn't really matter in what order I choose train and test. So I'm going to say the last 100 rows will be the test set. So I'm going to call X train X and then the first n minus 100 rows. Similarly for Y train. And then X test is going to be the last 100 rows. Okay, so now all we have to do to use scikit-learn's naive Bayes is instantiate an object, right? And then we do the usual .fit and let's print out classification rate for naive Bayes model.score X test Y test. So let's see how that does. So our model does pretty good at 87% accuracy. Again, 88% accuracy. So now the interesting thing about this is you can use any model from scikit-learn because they all have the same interface. So let's suppose I want to use the AdaBoost classifier, which is an ensemble method. I would just do from sklearn.ensemble import AdaBoost classifier and then just do the same thing. So I instantiate my object, I fit it to the training set, and then I score it on the test set. So let's try that. Okay, so AdaBoost doesn't do as well, which is surprising. Now it's doing better. Okay, so it does about the same as naive Bayes.